Okay, so this is a question about conjugate acid and base. This is essential. There's no acid cannot exist. No acid cannot exist without having a base. Okay? So it is actually acid is being defined because you have a base next to it. Okay? This color of the clothes is light compared to this, right? The same thing. These are all relative scale. And this is a very easy one, but when you come to the organic chemistry, you will see some bizarre statement. Okay? So something that you normally think that, oh, amine is a base. No. So for some cases, they actually, the one cannot behave as a base anymore. But in this case, is the simplest choice for the one, and then I have this showing you here. So you will see this. Look at in the left hand, it's all about the left side to define which one is an acid and which one is a base. And you say which one is essentially wants to lose the H plus donor. What's the other name for H plus donor? Recall? Anyone who want to say the molecule who wants to donate an H plus or who want to lose an H plus? Recall that is acid, right? That is an acid. Acid wants to like to lose an H plus. And whereas it's like a pitcher, okay? They throw, and because they can lose it and they are still forming something that is, and then they become their conjugate base. But the lost H plus is accepted by its neighbor, and that neighbor we call, what do you call? Base. So you just need to figure it out, and then okay, so I find out, and that acid becomes, you lose them, and that becomes their conjugate base, right? And this one becomes their conjugate acid. That's all it is. So it's very easy once you get the hang of it. Right. So which one, you look at that, and I can make sense SO4, oh, this is an SO4. So what happened to this one on the left? They lost an H plus, right? So this is their acid. This is their conjugate base. And what about the SO3 2 minus? Looks like they are the one who accept an H plus to become their conjugate acid. So this is a other form, which is this is a base. This is their conjugate acid. Right. So I can just focus on the one, which is this one too, S2 minus. Yeah, here. So what happened to the S2 minus? In this case is they are the one who accept the H plus. So this is actually the base. Right? And this is their conjugate acid. The water is now an acid because they lost the H plus, became OH minus. So this is an acid, and this is their conjugate base. What about the Cn minus here? They become HCN. So it's the same thing. The other one acts like the catcher, right? H plus acceptor. So this is their, on the left hand side, Cn minus is the base, and their result is producing conjugate acid. And the other one is obviously acid and form the conjugate base. Okay, so H2Se. So this is the one lost a 1 H plus. So this is an acid. This is the conjugate. Okay. And I mean the rest of them you guys can do. This is a base. This is a conjugate acid. So this is always I guess really the key word is the conjugate acid and base pairs. They always work in pairs, and this is something that you. Okay, so today you guys going to do the Beer's law, and I wanna